Okay, this next example that we have, okay, is the proof of inequalities using mathematical induction. Okay, so what you're expected to prove, again read the question, you need to prove by induction un is greater than 3 for every positive integer n. So this is your proposition, Pn be the proposition un greater than 3. Okay, then of course the next one should be the first case. So how to prove the first case? Given u1 is equal to 3.5, given to you already, so 3.5 obviously larger than 3, p1 is true. Okay, so there's no such thing, no need to handle what left hand side, right hand side. It's just common sense, just copy down the result. Next, step 2, assume pk true for some positive value of k, so uk should be greater than 3 for some k value. Then consider the next case. Your objective is to show that if uk is greater than 3, then uk plus 1 is also greater than 3. Okay, so how to handle this is, again, I have not used this result in yellow yet. Okay, so uk plus 1 is actually equivalent to 4 minus 5 over uk plus 2. Okay, but before we go into that, let me teach you a very useful trick. It is very difficult to show that some uk is going to be greater than 3, but if I shift it across instead, okay, it will be easier if I ask you to prove this to be greater than 0. So I'm going to try and prove this instead. So we consider uk plus 1 minus 3, and thereafter replace this uk by this result one more time. Okay, then of course right now all I need to do is to make the denominator common and combine everything. Okay, so 4 minus 3 give me 1, then make denominator common, you're left with uk minus 3 over uk plus 2. Okay, then, okay, always remember mathematical induction, I need to make use of previous result. So the previous result or previous assumption I made is uk is supposed to be larger than 3. So if uk is larger than 3, this is the numerator. Numerator must be greater than 0. Then similarly, the denominator, since uk is larger than 3, uk plus 2 also larger than 0. So what you have is a positive and positive effect. So end of the day, the whole expression must be greater than 0. Okay, this whole expression is greater than 0. And if it's greater than 0, shift it back across, your uk plus 1 must be larger than 3 as well. And then you have proven that with your assumption that pk is true, you have implied that pk plus 1 is also true. Okay, so same thing, conclude everything with your proper conclusion.